afternoon, everyone. Appreciate you all staying with us this late afternoon on a Thursday. I have a couple of panel members who actually came out of state, so I appreciate both of them. That's Anuja and Ken. I think what we'll do is we'll try to do a 5-minute, a little bit background about yourself and about your company, and tell us how you're trying to solve anything for your industry, for the national security, and for our country. So Ken, we'll start with you first, just because you were in that corner. And if you can give us a little bit of your personal background and how Delta Black is helping on the national security and in the industry.
Is this working now? Yeah. Okay. Hi, my name's Ken Plaks. I'm the Chief Science Officer for Delta Black, which is a drone company. And when I say drone, I don't mean like the little ones that you get at Walmart. This is a 330-pound mule that can do a variety of missions. My background was I was in the Air Force, flew jets for 30 years. Did flight test. Then I was at an organization called DARPA for another 10 years, doing a variety of things. If you saw a couple years ago, the Secretary of the Air Force was flying in a robot F-16 that was dogfighting a human pilot, and he was just sitting there. That was my guys. Delta Black is working on making really a kind of a revolutionary unmanned aerial vehicle, UAV, in that it is going to do what we would call Group 4 and Group 5, the big UAVs like Predators and Global Hawks. It's going to do 80% of those missions with what we would call a Group 3 or 330-pound drone at a price that's more like what you would pay for that Walmart drone. So it's an exciting time, and I am glad to be here in lovely Killeen.
Thank you, Ken. I appreciate you coming from California. I'm thinking you're probably really happy to be in Texas.
I work in Texas.
Okay, good. Glad. All right, Anuja.
Good afternoon, everybody. My name is Anuja Sonalker. I'm the founder and CEO of SteerTech, where we build autonomous ground vehicles. My personal background is in the area of cybersecurity. I started back in the defense sector, building distributed systems for cyber warfare and handheld communication devices for warfighters. And from there, I gradually moved, always in the cybersecurity space, but gradually moved to different frontiers. So going from enterprise systems to communication systems on fields, to then I moved into the automotive space, which was again a collection of distributed systems moving around. After I built some automotive cybersecurity systems, and I realized that the next frontier was going to be at the intersection of intelligence and cybersecurity. So I focused on, in the automotive space, so I focused on autonomy. And so Steer is built at the intersection of autonomy, cybersecurity, and intelligence. And we focus basically on yards, depots, industrial environments, any kind of structured environment that requires high precision. We focus on creating solutions in that space. Apart from that, in my other spare time, I actually focus on standards activities and encourage interoperability. So I'm also chairperson of the ISO standard for on-road vehicle cybersecurity and a few other boards where, the theme is to help build an interoperable, connected framework for various different organizations on a pre-competitive basis to be able to interact and work together for the greater good of others.
Thank you, Anuja. I appreciate you coming from Maryland to Texas. All right, Thomas.
Perfect. Thanks, everyone. Thomas Healy, founder and CEO of Hyliion. We do power gen, so a pretty attractive space right now, making electricity. And we're going after both the data center world and the defense sector, so two very hot places as well. So for a little bit of background, we've really invented a new way of making electricity. To give you a backstory there, if you go back 200 years ago, there was the steam engine. That's how a lot of power was made. there was this concept of a Stirling engine. The diesel engine hadn't even been invented yet. But even back 200 years ago, this Stirling that I mentioned, it was known that that was the euphoria of power gen. But for the last 200 years, it's been almost impossible to manufacture. So what we did is we said, well, there's been a breakthrough in manufacturing thanks to 3D printing. And so we actually 3D print this new form of engine or generator that we can put on site at a data center or on a military vessel and make all the electricity they need using whatever fuel you want to give it. You can give it natural gas, diesel, hydrogen, propane, truly fuel agnostic, and it gives you power plant level performance, but in a small modular box that you can put right on site, right at your facility. One of the fun ones that people usually like is we are the power plant on board the new DARPA ship. I know you just mentioned you worked for DARPA. It's a 200-foot vessel, and it's a fully unmanned autonomous, so not too dissimilar from what you're doing with autonomy, but think of like 200-foot ship, no crew on board, right? Underneath the deck is just engines and diesel fuel. That's it. And then on the deck of the ship are these two I-beams that go down it, and they can mount, the military can mount whatever weaponry, whatever systems they want on it. And then, in the hull of the ship, we're putting a few megawatts of power in it, and giving them an ability to really deploy low maintenance, very efficient ships. With a vision, the military wants to have thousands of these unmanned autonomous ships all around the world, sitting there monitoring, but then able to deploy on missions if and when needed. So we are the power plant on that, and then, as I mentioned, also data centers and even commercial applications.
Great, thank you. So Ken, I'll start with you first question. Central Texas is becoming increasingly recognized for innovation across defense, mobility, energy, and advanced technology sectors. We have some companies, especially with drones manufacturing, who are interested in this geographical area. The defense drone market is becoming crowded very quickly. What differentiates Delta Black beyond the specifications, as you mentioned?
Oh, okay. I'll answer that. I want to say that the boat was also my guys. The boat you're talking about. It's kind of not a fair question, because what makes Delta Black special is the specifications. We've built a 300-pound airplane that can fly for 28 hours, go 1,600 nautical miles, provide 2 kilowatts of electricity to a payload, and do all that for much less than $1 million. So it really is kind of a game changer. And what we did, the companies got some very experienced folks, and we also brought in a lot of folks that did operations downrange in the military, and then came in their second careers to work with us. And so we kind of had a really good understanding of the things that need to be done that can't be done today. And we put that together in a drone. And the first thing we did is we kind of did everything backwards. So normally when you're building an airplane, you build an airplane and then figure out how to hang stuff on it, right? We started with a payload bay, and then we built an airplane around it, which is kind of a different philosophy. And what that allowed us to do, and what our goal is, to kind of be the Hilux Toyota truck of the world for drones. One of the nice things about 330 pounds, I keep saying that number, and our airplane's called the Raider 330, is it is below the level where it has to be controlled with ITAR and EAR and all the other export controls, but it's still a useful size. And while defense has obvious applications, we can do logistics, we can deliver ordnance, we can do ISR, intelligence, surveillance, and reconnaissance. We could put jammers on there because we have 2 kilowatts of power. But you also might use it, for instance, in Texas, if there were wildfires, right? Wouldn't it be nice to have a satellite that just hangs overhead and acts as a comm relay through the valleys, and also is giving you real-time updates and video of where the fire is, right? Or again, since we're in Texas, the oil and gas industry spend a lot of time, effort, and treasure constantly monitoring their pipelines. Wouldn't it be nice if you could have something flying for 28 hours that's constantly monitoring it, whether that be with sensors or with cameras? So I think it's defense, but it's more than defense, and that's what we're after.
Great, Thank you. Anuja, we are seeing rapid advancements in autonomous systems, electrification, aerospace technologies, and defense applications. How are those industries beginning to overlap, and how are you seeing, you've been in business for the last 7, 8 years, and you have seen a lot of changes in these years?
That's a great question. Actually, we are seeing that these industries used to be separate before, but they're increasingly converging towards each other. And it seems like the physical AI and the AI is the overarching connector between all of them. And autonomy plays a central role in that, because autonomy is essentially AI in operation. Right? So if you think about the thoughts that you have, and then automation is the execution of those thoughts. So in that sense, that execution is actually colliding. It's bringing everything together. And we're seeing that defense, logistics, transportation, energy, even workforce, all of these are all converging towards one direction, and that is to become one connected infrastructure and to be able to operate efficiently, safely through that. So I think autonomy, and especially, for example, in the case of ground autonomy systems, we're seeing that originally when it started, it was about movement of vehicles. Now it's beyond movement of vehicles, it's about the infrastructure that it's become, and it's connecting the things you need to connect. It's about movement of people, movement of cargo, movement of assets, tracking them, and essentially, again, operations. So I think they're all coming together very with that same theme.
Can you tell us a little bit about one of the customers that you are helping, supporting them currently?
I can talk about some of the customers, but let's say one of the customers runs the world's second largest logistics network, and they move goods at next day speeds, right? So you, from wherever to wherever.
Do we get those boxes every day in our homes? Okay. We're not saying the names.
But the intelligence is not, the intelligence is in the network now. It's about how to move something from A to B in the fastest, most efficient way by software-defined things, by AI, and by physical AI, so that it helps you orchestrate and move those things. And so we are one of the pieces in that big, gigantic puzzle that makes things happen.
Right. Thomas, energy reliability and next generation mobility technologies are becoming major economic development conversations nationwide, especially in Texas. So how do you see those sectors influencing future investment and industrial growth?
So I had this awesome stat to lead in with.
Sure.
And I was sitting in the audience for the last presentation, and he used the exact same stat, but it's so important that I'll reiterate it again. China put 10 times the amount of power into their grid last year as opposed to what the US did, right? 500 gigawatts versus 50 gigawatts. So this AI race, it is going to be dependent or limited on power. Right, we're already getting to a point that there are warehouses full of chips, of compute, that are not being brought online because there isn't power available to actually run them. And this is going exponential. We just had one of the large hyperscaler companies on site, and they're talking about a single computer rack used to be kilowatts of power. Now it's in the hundreds of kilowatts. Now they're moving to megawatts and multi-megawatts. And I asked them, I think they were saying they're at like 300 kilowatts right now. And so you would say, okay, well, a megawatt, that's going to take you some time to get there, right? And they were like, no, we're thinking like a year or two we'll be there, and then we'll be at multi-megawatt in just a few years probably in the same rack. So think about that. They might have a data center that is bigger than this room, and a rack takes up a certain amount of space. Well, now if you 10x the amount of power that rack consumes, you need 10x the amount of electricity going into that same building. The grid doesn't have that available. And so you look at all this, and winning the AI race is going to come down to how much power you have. And that's where the grid's not there to support it. It just doesn't have the capacity. Data centers are determining they're going to move it on site. They're going to, and regulations are pushing an on-site power gen as well, because think about it, if a data center moves in next to you, guess what's going to happen to your electricity bill? They're going to be willing to pay a lot more than you're willing to pay for that kilowatt of electricity. And so that's where there's a big push. Just do it behind the meter, do it on-site power gen. It won't affect the community. But now these data centers need a technology that really enables on-site power gen.
How many other competitors you have right now in your, especially exactly what you're doing?
Exactly what we're doing, we are truly the only ones doing it. There are companies that we often go up against in bidding processes, right? I mean, there's the big behemoth companies like the GE Vernovas of the world, but you need a huge data center that you got to be in the gigawatt size or hundreds of megawatts till you're going to look at them. And then you've got companies like Bloom Energy, which if anyone has tracked that, I actually was looking at this morning, they're now worth $80 billion from being in the single digit billions just a year or two ago, because there's that much demand coming in needing power gen. And then, we're bringing this new form of tech that, we strongly believe it's a better mousetrap. It's a better way to do it to solve the same problem.
Right. Ken, Thomas mentioned about China, and I do not know exact statistics on it, but basically somewhere I read, we only manufacture drones like 1/50th of what China does in a monthly or something to that nature. So do you have any information and statistics that you can tell, like how behind we are on the manufacturing side of the drones?
Well, I think it's important to talk about, yeah, they make a lot of stuff, but a lot of it is the little drones you're buying at Walmart, right? I mean, so not all drones are equal to start with. The second thing I would say is that they do manufacture a lot of stuff in China, no doubt about it. At Delta Black, we're trying to make sure that all our stuff complies with the NDAA and everything. Even though we are not exclusively going to be military, we want to preserve that option, obviously. The other thing is, we're really focusing on manufacturability. So, the U.S. government, and I was in the U.S. government for 40 years, is a really hard customer to work for. And it tends to be very boom bust, especially for smaller firms. It's really hard for a small firm to ramp up. And then as soon as you ramp up, they stop the order, right? Because the conflict's over, right? Yeah. And they tend to preserve the really big Lockheeds and stuff because those are considered more strategic assets. And so one of the things that we've been noodling on at Delta Black is, how do I scale production so that I can use local resources? We're making our airplanes, at least at first, in Amarillo, is where our manufacturing spot is. And we're trying to design the plane in such a way that you could manufacture it anywhere, even maybe under license. And part of what allows us to do that, I think, is that all the hard stuff the stuff that used to be hard about drones, the microelectronics, the radios, the optics balls, the composites, all of that's kind of commodity now. We are a hybrid electric airplane for this, which means we have an engine running gasoline, but only to generate electricity as a generator, which then charges a battery, and then we're actually using electric motors. And there's a lot of good reasons to do that with the kind of airplane we built. But all the stuff that's gone on with Tesla and all these other electronic vehicles that are coming around has actually taken something that was very expensive and commoditized it. And now I can get it anywhere. And it's always cheaper to buy one of a million than one of 100, right? And so I think that is kind of our path out of the wilderness. We have to design it smartly, and you're going to give up some performance because there is no free lunch. But if I can give up, 2% in range and 10x in cost, I think that's a good trade.
As we're talking about scaling, Anuja, workforce development remains a key challenge across, advanced industries. what skill sets and workforce capabilities are becoming increasingly important, not just for your industry, but for the future?
That's a great question. I think if you look further out into the future, the biggest skill sets are leadership and really solutioning. Because for all the tasking and task related things, we are going to have AI and agents and all of these things to do that for us. But really understanding how do things go together? How does interconnections work? How does solution, what is the solution? I have a problem, how to solve that problem? Those kind of things, I think that skill set is going to be very important. And then the second skill set that's going to be very important is how to use AI and AI related technologies properly. Just like, an example of when you learn to use a blender, you learn to use how to operate the blender, but you also learn how to operate it safely so that you don't cut your fingers on it. Right? The safety part of the operation is just as important, how not to use it. So same thing with AI and AI enabled technologies. We are going to have to teach and have our workforce understand how to use it, but also where the boundary lies of how not to use it. And I think that's something we don't concentrate on, currently that's equally important is the safety lines and the assumptions.
Valid point. Thomas, can you tell us, go ahead.
Yeah, I was going to add to kind of the workforce side of things. So my belief is we don't know how the workforce is going to evolve, right? I mean, what has happened in the coding world over the last 6 months, I definitely didn't see it coming, but it's gotten to a point where you can now download Claude code yourself, not being a software engineer, and by end of day, you can have some kick-ass software programs developed and make your life more efficient, just things that you would have said, I need a team of 10 software engineers just 7 months ago. I think there's another big wave coming with humanoids, and to put a story behind that, there's on the board of trustees of Carnegie Mellon, and there's this company that recently came out of it, just a couple of year-old company, already has, I think, a 15 billion valuation now, so pretty wild. They have their humanoids, or the software, watch videos to learn how to perform the tasks that need to be done. And then, that uses an AI model to then go train the humanoid. So think about that. Like, I'll give you an example. They had a customer demo going on. They had this humanoid was doing tasks. Mid-demo, the humanoid started limping. And the whole team was like, all right, we've never seen the humanoid limp before, but this might be an investor, so let's not say anything. Let's just keep going. All right, so then the demo ends, they tear it down, and they're like, all right, what happened? Why did the humanoid start limping? And they figured out in the knee, one of the little actuators that causes the knee to bend broke and stopped working. So then the humanoid, who was trained off of just watching YouTube videos, said, hey, my knee hurts, or my knee's not working. Well, what does a human do when their knee starts hurting or not working? Oh, they start limping. All right, well, I'll start limping, right? So think about that. If you want your house painted through the middle of the night, if you want the vents changed in your air conditioning ducts, all those things, you should have a humanoid watch YouTube to do it. So that's where I think it's tough to predict how all these different jobs are going to shift and evolve over the next 5-10 years, but they're going to.
Totally agree with you, and I think our academia has to be changed in the next 5 to 7 years. It's going to be very interesting to see how education changes. As we're talking about that, can you talk about, Thomas, a little bit about your facility and how close that is from here, and tell us a little bit about what kind of employees that you have, staff you have, and what exactly happens on a day-to-day basis in your facility.
So we've got one of the leading 3D printing factories in the US. To give you a sense, it's probably 2 to 3x the size of this room. Now these aren't your normal 3D printers that some of you probably have at home that you sit on your desk and they print plastic parts, which are awesome. If you haven't bought one, go do it. It's awesome, go make some parts. But these machines that we're operating are about the size of like a small box truck. So these are big, big machines, and they actually print metal parts. So a lot of people don't realize that the 3D printing industry has evolved to you actually now can make metal FAA approved components, right? So aircraft approved components out of these 3D printers. And so we've got these machines lined up. Right now, they're running, they're making parts. When the team goes home tonight, they'll still be there running through the middle of the night, making parts. And through the weekend, through the long weekend, right, Memorial Day, they'll still be there making parts, even though no one's at the factory. And what the reason we use 3D printing is kind of unique is we're able to make components or parts that never could have been manufactured before. So if you think about subtractive manufacturing, like a CNC machine, a lathe, a mill, the conventional manufacturing, you're limited. Like, you know, if you're making a part, there's no way to get to the center, the inside of the part and put a tube or a passageway, right? With 3D printing, it totally unlocks the design of what you're making, and that's what we're doing. So we've been able to design components, going back to my first statement, take a 200-year-old Euphoria technology and now actually manufacture it thanks to 3D printing.
Great. So you do not have any humanoids working there?
No humanoids yet,
Okay.
but hopefully someday soon.
I need some of those in my home.
Ken, how important is access to testing environments, right? So for you guys, I think infrastructure testing and regional partnerships with scaling emerging technologies. Is it easy to do the testing right now? Do you have to go to a DoD approved sites to do those kind of testing? Because here in Central Texas, we have a lot of places that a lot of missile companies and others are doing these kind of testing as well. So I thought I should ask you that question.
Yeah, thanks. You know, so if you want to go fast in technology, you know, the old school way of doing things was to have this nice waterfall, you know, where I build things and I test them and I build them and I test them, and eventually I actually make something and I take it out and I test it, and then I find it didn't work and I go back to the beginning, right? You know, and it's pretty slow. If you contrast that with the way folks are doing things now, is I really need to do a little bit of design, a little bit of test, and a little bit of evaluation and redesign, right? And if you look at, for instance, SpaceX, which I believe is Texas here, and you know, they kind of said we're going to crash some of these rockets, right? Because they're not fully baked yet, but I'm focusing on this pump, and I can only get this data by actually flying it, for instance, right? And so we've taken a very similar approach. And, you know, we've had what we euphemistically call, you know, a couple of unplanned learning events. But you know, that is how you go fast. And you can crash, you know, a 10-ounce drone in your backyard with minimal impact. A 300-pound drone falling down is going to, you know, cause a bigger impact. And so we really need to go somewhere where you can get folks out from underneath you. And you're not going to do that in McKinney, Texas, where we're building this drone, right? So we have been going to, you know, some FAA ranges. There are FAA regulations. The other place that we're looking at actually here is at Fort Hood, where you know, where the base commander and the military control the airspace, can give us reserve ground space so that we don't hurt anybody if we have another unplanned learning event.
Great. Anuja, what about you? I'm sure the testing for autonomous vehicles might be also a little bit of challenging sometimes. So you can't do it in the middle of the street or anything like that. So how are you guys doing that?
So testing is definitely challenging. You have to recreate some of the environments that you would end up operating in. Half the battle is building the technology, and greater than half the battle is in actually testing it out in real world conditions, and that testing never ends. That's why it's greater than half. There's always a tail to it. We do a lot of our testing on, we do the first round of testing first via simulation, so we get some of those baselines, but then we do a lot of our testing on grounds that we have created. Actually, so at Steer headquarters, we have recreated some of the areas that, you know, potentially our customers operate in. But then we have to go beyond that. So there are test tracks, test sites that we operate in. The state of Maryland, where we come from, has provided 10 different types of sites for us also. Aberdeen Proving Grounds, so it's a military proving ground. We have used those sites as well. Airports, airport sites they have made available to us, and then some factory and industrial setting as well. And then some of our customers have actually allowed us to operate on their sites as well to do some testing. But if I zoom out from all of this, the underlying message is that you cannot underscore the importance of testing. The real world testing is so important because no amount of simulation will allow you to actually characterize things 100% correctly. And the devil is in the details, because high precision autonomy, high precision operation, it can make a big difference. So, having access to quality venues where we can recreate these operational scenarios is actually of very high importance for us when we select the state or the partner or the organizations where we're working with.
Thomas, can you tell us, we have Economic Development Corporation officials here, city council members and city officials and others. How do you think we are trying to attract industry partners to come here in this community? We have Fort Hood right next door. Austin is about an hour and a half plus, depending on the traffic. With all that to say, how do you see, and biggest challenge, of course, everybody is talking about is data centers and then energy and so forth. How your company can partner up with cities or economic development corporations to help them, guide them, so forth. What's your take on that?
Yeah, maybe I'll start with how did we end up in Cedar Park? So I actually founded the company in Pittsburgh, ran it there for a few years, and then got to a point where could not find the talent we needed, couldn't find individuals who had been through startups before and were used to like the chaos, the mayhem of being in a startup, and started posting the same jobs in Austin, Texas. We also looked at Silicon Valley, but the costs were just prohibitive. It was like, all right, we're not going there. And then posted the same jobs in Austin, Texas, and people that were applying were like, oh, this is my 6th startup. Like, this is what I do. I love startups. And that's when we decided to move the company to Texas. And then we did get a economic development incentive from the city of Cedar Park, which was one of the big helpers of actually going there. We looked at a lot of areas around Austin, and Cedar Park put a very attractive offer, so we selected a facility there. And then what we found has been fantastic about being in that corridor is you can get individuals who have totally different lifestyles to converge in that same area, right? You can get individuals who want to be downtown Austin, the city life, who can drive 30 minutes up to be in Cedar Park. You can also get someone who lives in Leander who has acres and acres of land, and they're able to come down. And so it's been good for us because we literally have all different types of jobs. We've got engineers, we've got individuals that are on the shop floor making parts. So it really requires a pretty wide breadth of individuals. So I'd say, going to kind of your point though, it's what attracted us to Cedar Park. It was the economic incentives that were put in front of us. That was a big driver. And then there was this overarching goal for us to be in Texas and in the Austin suburbs directionally. And then what we found is, it all comes down to what workforce you can find, right? And the good news is there's an awesome workforce in this area, and I think you guys actually have a very amazing leg up with having the military base right here.
Do you see your company working with the economic development corporations because everybody is worried about the energy side of the things? Do you think that you can partner up with the companies who are bringing the industries, but they are looking for the energy side of the things, and the scare of the city cannot provide that much of the energy? Do you see that can be a partnership?
I would love it to be, yes, yeah. So, my goal is, long-term vision is every facility, or probably not every, but a lot of facilities you would go to would have our Carno power modules sitting right outside, and it would really transform the utility grid, right? The grid was developed in the way it is, where you have a big power plant, and then you have all these kind of tentacles that come out of it, the transmission lines, to get to these end destinations. But the problem is if one of those tentacles gets cut off, well, what happens? You get a blackout. Everything goes down. So when you look at the fact that the grid needs to be transformed, 60%, it's actually over now, over 60% of our utility grid is at or past its life expectancy. So starter is the grid needs to be transformed. we believe let's not go do it the way it was done in the past, where you do these big power plants and all these tentacles out. Just put the power right on site, make the electricity there. And then when your neighbor loses electricity, guess what? Your lights are still on, right? And maybe you're actually making enough that you can feed it over to them and keep their lights on as well. And so to your question though, if there's a shortage of electricity, this is a pretty economical way to actually get more power in the area you need.
Anuja, as I know you're working with big corporations as well, but do you see that your autonomous vehicles that you are converting the current vehicles to becoming autonomy, how you're seeing that can be helpful for small to medium-sized businesses, or how they can help the city, municipalities, and state? I mean, do you have some ideas on that?
I think it could be a game changer on so many levels. Think of it like a horizontal, like a Microsoft Word that can be used to write a poetry. It can be used to write a technical document. It can be used to write a financial report, etc. You can use it for various applications. So being able to retrofit autonomy onto an existing vehicle itself is like a base. So it doesn't matter what the vehicle is, it does whatever its job is. Retrofitting automation to it now allows you to be able to put that vehicle into operational execution, doing what you need to do with more efficiency, more safety, and to be able to just do more output with that machine. The whole purpose of automation. Small businesses are generally, from our conversations, what we have found is that this technology is not only for the large enterprises, even for the medium-sized businesses will benefit even more, because they are at the point of scaling and growing, but they cannot either find the right talent, or talent moves linearly, whereas automation moves exponentially. And so you're able to do more with the resources you have while you nurture and build your talent to actually operate it instead of doing the day-to-day. So they are a very high potential to be able to benefit. And then cities, municipalities, etc., we find that there are so many, they own fleets, and these fleets are aging. And now, in order to keep up with more efficient things, they have to go and recapitalize their fleets. They have to repurchase. Instead, you can breathe new life into these older, aging fleets by breathing new intelligence into them. And so conversion actually becomes a more capital efficient way of trying to claw back some of that innovation into it. So,
can you give us some ideas on pricing? So, for example, Ford F-150, if you want to convert that to being an autonomous vehicle, how much we are talking on that conversion? People have some idea about that.
Okay, so
not asking for your exact numbers, but
sure. So for like an F-150 type of vehicle, we're looking at somewhere between $8,000 to $10,000. It's a very, very small number.
So $8,000 to $10,000, we can have Ford F-150 to become an autonomous vehicle and can be
controlled and maintained by a human, and at a human touch, you can actually make it
from an app.
From an app.
Okay.
Can I ask the controversial question? Is Musk right that we just need cameras to go full autonomy, or do you need LiDAR?
You don't need LiDAR. You definitely don't need LiDAR. It all depends on the application, and it all depends on the environment, and it all depends on the speed of operation also. So he is not wrong to say that you don't need LiDAR. I will leave it over there because the way he applies and uses his technology, is different.
Ken, to a pricing question, I know you mentioned that yours is cheaper than other thinking drone companies, but can you give us some pricing structures on that as well, for the audience to know how the technology is changing and pricing structures are changing?
Yeah, so I've been in this job for 2 weeks, and I don't really want to get fired by disclosing proprietary, but we're looking at less than $700K for the drone. What allows us to do it is kind of what I alluded to before, is that we've commoditized all the parts. To give you a feel, we have a little 3D printer to make little brackets and stuff, but we actually don't have a machine shop, which is shocking because we're in a hangar. Every hangar in the world has a machine shop when you're building an airplane. and we don't. The reason we don't is because we don't need it. We can actually order stuff. You asked a question about, the community and stuff. Yeah. One of the things I think that I was kind of surprised and gratified to find up in McKinney and down here as well in Killeen is you need kind of a critical mass of folks, right? It's not enough for me to plop a factory down in the middle of nowhere and we, with great folks, but there's just me, just my little factory. But having a cluster of folks to support each other. For instance, we were reworking our high power electric system, and we were able to bring someone across the street from Albus Aviation, which is kind of an affiliate company of ours, who actually helped us put this thing in because none of us had actually done it before, right? And we were able to go out on the street and just buy one because it's not the kind of thing they have at Granger, but there was a place that had it right there. So you get the critical mass, and it's a multiplicative effect on your velocity to execute, not waiting 3 days for the Amazon to deliver something and then someone to fly out from Boston to help you install it.
Great.
So to that point, you said, Abdul sir, you said something earlier that resonated with me is Central Texas, and this region actually is, it's actually an innovation corridor because you have the right blend of all the ingredients you need. You have a military presence, you have innovation centers, you have a workforce that is eager and willing to learn and absorb and implement. You have a transportation corridor, and you have all these innovative companies wanting to come here. So you have the right mix here to create that innovation corridor here in Central Texas, in this region. And I resonate with that critical mass comment. That is what is attractive to innovative companies, is why we want to come here, is that mix.
I know, Thomas, you have already told us about some of the pricing structures and so forth, how you guys are changing. Do you want to add something to that?
Yeah, I think I'll put some numbers to it. So our goal is you actually can deliver electricity for cheaper than what you could otherwise buy it from the utility. So our upfront capital cost is obviously more, right? If you plug into the grid, usually it's no upfront capital costs. There are instances where you got to buy your own transformers and stuff like that. But it really comes down to what's your cost per kilowatt hour, something that I'm sure everyone in the audience is familiar with. You get your bill, right? And it's this is your transmission line cost, this is your actual electricity cost, and it all boils down to 20 cents per kilowatt hour or something like that. Same thing, not going to name names, large box retailer though, in New York. We did a whole cost study with them. They spend 22 cents per kilowatt hour right now at that facility. And even amortizing our asset costs, right? So including the upfront cost, we would come out to 17 cents per kilowatt hour. So 5 cents cheaper than what the grid is.
Great. Ken, what misconceptions do people often have about modern defense and advanced technology companies?
I think a lot of people think they're out of reach. We have a guy that in the office that used to drive a truck, and now he's assembling drones, right? It's a very different skill set, but he was a well-educated guy, good with his hands and whatever, and so I think a lot of folks don't feel like it applies to them. It's not maybe an option for them, and I think we've got to a point where actually it is, right? I mean, I would say the other thing is that it's a little bit of a false dilemma, defense or commercial, because there's so much blending. When I was at DARPA, I did microelectronics. And 40 years ago, the US government was 40% of the worldwide microelectronics market. Now we're less than 0.5%, right? And so, and yet all the electronics are way better. Right, and a lot of that is the economies of scale and things that we were talking about before. And part of the reason why we designed, that 330-pound is because there's a regulatory cliff there that allows us to sell it to fire departments and, companies to do pipeline surveillance. But then the military also has military utility, for the military. So I don't think of it as an either or. I think of it as a both and lately, especially since the parts themselves, I kind of said this before, have kind of been commoditized. It used to be, I've got this special widget, and it's classified, this little motor, but that, that's not the case anymore. It's anybody can buy it. It's all the intellectual capital you put in and make it useful, which again is lately with the way we design systems, largely software defined.
Anuja, there's a lot of parents here, and when a kid comes in, their kid, and right after high school or after college, after they spend $60,000, $80,000 on a 4-year degree, and they say, hey, mom and dad, I'm going to work for a startup. They're like, no, you need to get a real job, and there's a lot of those kind of conversations starts happening. So what will be your message to parents whose kids are coming and wanting to work for autonomous vehicle company and who is a quote startup? How do you be able to give your briefing to that parent?
So I would tell the parents this: when your kids are young, right, and they have their minds are still open, let them work in an environment where they have maximum exposure to a lot of different things. The thing about a startup culture, chaos culture, is innovation comes out of that early chaos. And in order to, and I don't advocate early chaos, but it has its place. And after that, you have to put process on it because it eventually has to become a business and all of that. But at a young age, they will get access and exposure to a very broad skill set and to be able to do many different things. If you work for a large corporation, the larger the corporation, the smaller the role. You're a number. And you will have your own silo of what you do, and then you hand off to somebody else. And what you learn is a very narrow skill set. If you work for a startup, you get a much broader skill set. So young minds, broader skill set, you are setting your children up actually for a lot of success in the future, because as I said before, the ability to think through and solve problems, solutioning, is the single biggest skill set we can give our children, because the nature of jobs is just going to change.
So Thomas, you are one of the youngest CEOs for a publicly traded company. So I'm sure anybody can Google Hyliion and get all the information and tell about stock pricing, so forth. So here, parents will feel a little bit, better about their daughter and son going to work. So why do you think, and I know it's went really fast for you guys, and maybe give a little bit of a history on that too. How do you feel about the startup culture, being in a Carnegie Mellon board of directors? I mean, you're going and also advising the president and the provost and others too. So give a little bit of that background.
Lot to unpack there. All right, so the journey started the company in 2015. We went public on the New York Stock Exchange in 2020. We raised $750 million through that public offering, and market cap of the company shot up to $10 billion. It was wild and crazy times. It has come back. But it's been a good couple of weeks though, if you do go Google us, but we had a good earnings call. I think education is going to evolve fast, and it is already starting to, but the reality is all of us learn differently, right? Not one person in this room is going to learn exactly the same way. AI is going to know how you learn best, and it's going to be able to create curriculum specifically for you. So I think education is actually going to evolve a lot into how do you team build? How do you work with others, right? How do you collaborate and solve problems together? That is what education is going to become. And learning about thermodynamics or stress analysis or things like that, frankly, I think it's a pretty progressive view, but I think AI is going to figure out how to teach me better about how to learn stress analysis than sitting in a classroom of 200 students all trying to learn the same way. With that, going into a startup, you're signing up for a chaotic journey. You just need to know that. There's going to be major ups, major downs. But just speaking with someone who he said that this gentleman has done unbelievably well in his career. He's in the Forbes 400 billion, he's one of the richest 400 individuals in the whole world. And he said his son just got a offer from a startup in California for starting salary north of $300,000 a year, and he is in his sophomore year of college, and they're asking him to drop out and come join them. So first thing, remember how I said we didn't move to California because of the cost? So just remember that. But that individual is going to go there, and they're going to be on an accelerated learning journey, right? You're going to learn how to team build with others, and when you go home at night and you realize you got to solve this problem, you can probably go open up Claude or ChatGPT and go learn a lot about how to the physics behind it, which frankly 3 years ago we didn't have.
All right, I think I'm getting hooked. So first, thank you very much. We did not got booed over AI saying that many times. So I'm glad for that. Thank you so much, each of you guys, for joining us here. Over to our chairman, Mr. Fox. Thank you.